of the notes page, last new notes of the 9 weeks and almost the last new notes of the year. So what is this? Wednesday, 2/28. Tomorrow's leap day, right? Only happens every 4 years. Number 2, consider the region S bounded by the graph 1 plus square root of x, y equals 1, and x equals 4. Okay, well, these are almost all calculator problems. Find the volume of the solid formed by revolving S around the line y equals 3. Well, let's graph and see what we've got here. 1 plus square root of x, y equals 1, and x equals 4. Okay, I can't graph x equals 4, so let's graph what we have, and then we'll figure out where x equals 4 shows up. As always, almost always, I feel like your window is never perfect when you first hit graph. So I need to see more in the y direction. My x direction is probably fine because they intersect here, and then x is 1, 2, 3, 4. That's there. So I think my x's are fine, but my y's need to go up a little bit more. So I'm going to go -1 to 6 on my y and see if that works for me. Yeah, that'll work because x equals 4 is 1, 2, 3, 4 right there. So I guess I could only go to 4 or 5, but it's good enough as it is. So I'm going to sketch what I know here. X, y. So the square root of x plus 1, or 1 plus square root of x, starts at 1, 1, 1, 4, 2. So I know what a square root looks like. There's y equals 1, and there's x equals 1. Or x equals 4, excuse me. So here's the area. And again, if we were doing area, it would just be top minus bottom 0 to 4 dx. But it's not an area problem. We want to rotate that around y equals 3. Okay, so y equals 3. My axis of rotation is right there. So probably the first question, unless you want to graph it, is can you tell if this is going to be disc or washers? Washers. Somebody in a different class phrased it this way: if your area region is sitting on your axis of rotation, then it would be a disc. If there's space between your axis and your region, like this empty space, then it's going to be a washer, because that empty space is going to be like a void in the solid. So I know these are washers. So I'm already thinking big R squared minus little r squared. Big circle minus a little circle. Alan, I'll put you on the spot since you asked earlier. You know what I'm going to ask you. It's dx. How did you know it was dx?
Because it's rotated on the y, so it's on the y line, and then you have to cut it vertically.
Good answer. You're rotating around a y line, so that means you got to cut vertically. Your slices will be dx. And if your slices are dx, then that kind of determines everything else. Like everything has to be in terms of x. So, Leo, what would your limits be?
That would be 0 to 4.
Good, 0 to 4. Especially good since I didn't have it labeled. Y equals 3. So now I need to figure out big R and little r. Big R is, again, the distance from axis to outer edge. and little r is axis to inner edge. So axis to outer edge, that would be that distance right there. Axis to outer edge. So can you see how long that line is? Or how long that radius is? How long is it? Careful. Here's my x-axis down here. So how long is that line? 2. If you need to sort of back up and think about top minus bottom will always work if it's an up and down line. Well, the top is at 3, always. The bottom is at 1. So my outside radius is 2, a constant 2. So the outside of this thing sort of looks like a cylinder. I'm trying to do this one without drawing, for those that don't like to draw. I'm sort of fighting my urge because I want to draw it and see it, but you don't have to draw it. So the outer radius is always 2. So the outside of this thing is going to look like a cylinder, but there's a hole in the middle of it because there's this inner radius. And I'm still thinking top minus bottom to find this inner radius. Well, the top is 3. That's the easy part. What about the bottom? What about this curve? What is that curve? Yeah, that's 1 plus square root of x. So 3 minus 1 plus square root of x. So I guess you could leave it like that, but that's going to be a lot of typing when it comes to the calculator. So I would go ahead and distribute that minus sign. 3 minus 1 is 2, and then minus square root of x. But you really don't have to do any algebra. You can just jam it all in the calculator and have the calculator do everything. Okay, I think we're ready for the calculator because we've got our main formula here. We know what big R is. We know what little r is. So now we can go to the calculator and see what we get. So math 9, 0 to 4, 0 to 4. Pi times big R is 2. 2 squared is 4, but again, you can let the calculator do the work. Pi times 2 squared.
Can you put the pi in front?
Absolutely, you can put the pi in front. I think we mentioned that yesterday. And so Miss Murray and I had probably too long of a discussion about whether to put the pi in front or not. I'm glad you asked because it makes the calculator work easier. The only reason I'm a little hesitant to do it is it's easy to see that this is a circle minus a circle. Once you take the pi out front, it's still completely mathematically accurate. It's just now it doesn't look like circle minus circle. So sometimes you'll lose a little bit of the conceptual understanding by taking the pi out front. But mathematically it's fine. So yes, you can. Is the long answer to your short question. Okay, I've already started, so I'm just going to leave it in there. Pi times, okay, little r is a little bit trickier. Open parentheses, 2 minus square root of x, close parentheses squared, dx. Ooh, had to think about that one for a little bit. Again, you take the pi out front, it's completely accurate. I leave it in there sometimes because now I can tell by looking at my calculator this is a pi r squared minus pi r squared problem. 41.888. Questions, comments, concerns? Number 2. Number 3. Consider the region bounded by the graphs of y equals x squared, y equals cube root of x, and revolve that around x equals 2. X equals, that's going to be a this way revolution, which means it's going to be dy. maybe I'm getting ahead of myself. Let's graph what we know here. X squared. Cube root of x. I think there's a cube root button, but I'm just going to do x to the 1/3 rather than trying to remember where the cube root button is. X squared, cube root of x. So there's x squared. There's cube root of x. I feel like I'm fortunate that my window is small enough to see that. If your window is like your normal -10 to 10, you might not even see where the little overlap is. Right? It's too jammed up in there. Now, if that happened, surely you would think, well, I just need to zoom in and see what's going on. I just opted for the zoom in button, see if that works for me. And I think that's going to be fine to see what we need to see. So we're talking about that little area in there. And so they intersect at 0, 0 and at 1, 1. One of them's the parabola, and the other one is cube root of x. So now I can see who's top and who's bottom. So here's my area. But revolving around the line x equals 2. So I'm going to come out of the page, around x equals 2, back into the page, and around. Last time I didn't draw the picture. Do you want me to draw the picture, or shall we just do it without the picture? Draw the picture? Okay. The picture, I think the picture helps, but some people don't want to draw it, and that's fine. I'm gonna go a little out of order. I can tell already there's an outer radius and an inner radius. And so some people are going to just jump in there and like, I don't need a picture, like it's pi r squared minus pi r squared. I don't really know what it looks like, but so what? There's my r's and I'm ready to go. But some of you want to see the picture, and that's okay. I would usually draw the picture as well. So if you want to see the picture, you have to mirror it across. So this point that's at 1, 1 would go there, and that 0, 0 point would end up right there, because it's 2 away from the axis, so it ends up 2 away on the other side. And then I can just mirror the bottom part looks like that, and the top part looks like that. And so there's my, I don't know, what shape, is there a name or a description? What does that look like? Is there a name for that? Okay, a bowl with a hole in it. Yes, that's fair. Upside down bowl with a hole in it. That's fair. I was thinking kind of a ring, but like with slanted edges. So, if my ring was like bent out or something.
It's got like the onion shape.
Okay, an onion ring. That's probably the best one. It's like every year I ask for your descriptions because you come up with better ones than mine. I like onion ring. That's good. Because it's kind of slanted out.
It looks like some black hole distortion.
Okay, so definitely a washer problem because there's a hole in it, whether you think it's an onion ring or a bowl with a hole in it. So we're definitely doing washers. How about my slices? Are these dx slices or dy slices? dy, which is kind of a bummer because now everything has to be in terms of y. So speaking in terms of y, Anders, how about my limits for integration?
0 to 2 or 4.
But I need them to be y limits, so I got to think from bottom to top. So from left to right, yeah, you're thinking like 0 to 2 or maybe 0 to 4, but neither one of those really works because this is a y problem. 0 to 1. And we'll go 0 to 1. We already said it's a washer, so I know it's pi r squared minus pi r squared. And to accommodate Ian's request, I'll put the pi out front. The other problem with putting the pi out front every time is sometimes people just forget the pi altogether, and they do r squared minus r squared. Like, wait a minute, these are circles. Like, you got to have the pi in there. All right, big R has to be in terms of y. It's a right and left thing, so I'll do right minus left. You can always come back to, if you need a length of something, you can always do right minus left or top minus bottom. So right minus left, looking at R, the right-hand side attaches to this. What is this? That's 2. The left-hand side attaches to, for the outer radius, attaches to this. What's that? Which one is that? It's okay, here's where we have to be careful. It is the cube root of x, but I have to get it in terms of y. So it's y cubed. If I move this around, if I cube both sides, it's y cubed. So you have to locate the right equation, but then put it in terms of y. So y cubed. Okay, so 2 minus y cubed. We didn't do this on the last one, but you can always check these. Basically, at the top, I can tell that my radius should be 1. So if r is 1, if y is 1, r should be 1. 2 minus 1 cubed is 1. So I like that. At the bottom, r should be 2. So when y is 0, r should be 2. When y is 0, r is 2. Okay, so that checks out at least at the top and the bottom. That gives me some confidence that I got it right. Little r, again, you can always think right minus left. The right-hand side is 2. It's not changing. The right-hand side is 2. The left-hand side is y equals x squared. But I can't use x squared because this is supposed to be a y problem. So what does x equal? Square root of y. I don't remember if I said this yesterday. This is enough in terms of showing your work, going to the calculator and giving me an answer. That's enough because you've told me who big R is, you've told me who little r is, they're in terms of y. Like, you're good. If you want to just write the answer down next, that's fine. I'm going to take the step of showing what I'm going to write or type into the calculator. Especially since this one's kind of weird. Weird in the sense that big R and little r both have a variable in them. A lot of times one of those is constant and just makes the calculator work a little easier. Okay, yeah, and I like the pi out front on this one because this one's already messy enough. Let's get the pi out front and not worry about it. 0 to 1, open parentheses. If you're comfortable switching x and y, you can do that. Saves you a few keystrokes. If you want your calculator to look like your paper, then type the y in there. That's okay. 2 minus y cubed squared minus 2 minus square root of y squared dy. That one definitely takes a little bit of thought. 4.114. Whether you use x or y is similar to what you do with pi. That is, one way is easier in the calculator, but another way I think makes more sense conceptually. So the concept is you're in y, so I'm going to use y. If you're comfortable just changing your y's and x's, and that way you get to use the easier button, it's fine. Number 4. Let f of x be that thing, g of x be that thing, although they give us a picture. Let R be the region bounded by the graphs of f and g, as shown in the figure on the right. Okay, it's nice when they give us one and we don't have to graph it and figure things out. You know what? I am going to have to figure something out. I may as well figure it out now. Do you know which one is f and which one is g? How do you know the top one's f? I agree with you. Okay, because I know what a sine graph looks like. Sine graph starts at 0 and goes up and looks like that. And there's been some adjustment to the period, but that doesn't affect the shape of this graph. So yeah, I know this top one is f of x, and the bottom one is g of x. Another way is that's an upward-facing parabola. So yeah, the -2 and -4 maybe are strange, but it's an upward-facing parabola. Okay, so I figured out who f and g are. Find the area of R. I'm going to press pause and let you find the area of R, because I think that is a review question. It's going to make finding area easier because I don't have to type all that stuff in again. I can just do math 9, 0 to 4. Hey, speaking of pies, why don't I have a pie out front on this one? Yeah, it's not revolving. But sometimes we get in the mindset of pi r squared minus pi r squared. You're like, just stick pies on everything. Like, well, wait a minute. There's no pi in here. There's no revolving. There's no circles. This is just top minus bottom, or y1 minus y2. dx 25.946. Okay, this was, by the way, this one is a review of everything in the unit. There's like 3 main things in this unit, and there they are. Area between curves, that was part A. Part B, cross sections perpendicular to the x-axis, like that, that's dx, equilateral triangles. So dx, the area of equilateral triangles. That's one that you just need to memorize. Do you have it memorized yet? Root 3 over 4 side squared. I'm hesitant to draw too many triangles coming up out of this because I think I'm going to be rotating it next. But so there's equilateral triangles coming up out of the page. Root 3 over 4 s squared. S is top minus bottom. So that's just y1 minus y2. And even though that looks kind of disjointed, all those pieces strung together, that's enough work to show. You can now go to your calculator because you're integrating area. You got the formula for area, and then you got the formula for S. Now, I would probably show one more step because I want to make sure I put the right thing in the calculator. Root 3 over 4, 0 to 4, y1 minus y2, all squared. Oh, hit the wrong button. Careful with parentheses, careful with squares, make sure you're squaring the right thing. again, y1 minus y2, and then I'm squaring y1 minus y2 dx 88.859, and that's a volume. Always, always, always 3 decimals unless otherwise specified. So that was the cross-section thing. That was the second thing this unit. And then the third thing this unit is revolving R about y equals 8. It looks like this thing goes up to like 6. So 7, 8. We'll say that line dividing the problems is y equals 8. So we're going to rotate around y equals 8. So a couple of questions for you. Is this going to be a dx or a dy problem? Dx, good. So is it, or not so, they're not related, is this a disk or washer problem? Are my cross sections going to be disk or are they going to be washers? Washers. There's a hole in there. There's a space. If there's a space between your axis and your curve, they're going to be washers. And if we're going dx, we'll go 0 to 4. Alright, so now we need to think about big R and little r. So I'm going to press pause. A washer, so r squared minus r squared, need a big R and a little r. Top minus bottom for big R, top minus bottom for little r. That's enough to go to the calculator, but I think I'd probably still write it out. And I'm going to write it out in terms of y1 because that's what, g of x is y2. Better be careful here. F of x is y1. So 8 minus y2 squared minus 8 minus y1 squared dx. Pi out front just to make it easier. 0 to 4 parentheses 8 minus, whoops, that one's supposed to be y2. 8 minus y2 squared minus 8 minus y1 squared. That's a big number, but think about this shape. It's a big shape and it's being rotated around an axis that's way up here, so that's going to be a large shape, especially compared to that last shape we just did. So it's hard to make sense or hard to know if your answers are reasonable or not, because I don't visualize what 1,000 volume is, but I can at least visualize that it's that shape. This revolve shape is way bigger than triangles coming up out of the area, way bigger than that. So that's a large number, but that's okay. Okay, so that's it for new stuff for the 9 weeks even. And again, that last problem was a good one because that's the 3 things that are on this unit. Area between curves, volume with cross sections, and then 3 is still volumes with cross sections. They're just created by rotating something, so all your cross sections are circles.